So now, in this video, we have a 555 timer integrated circuit right there. I'm actually using an NE 555, but pretty much any 555 should work about the same. We have 5 volts powering this. Right now, the output is low. That is pin number 3. To get the output to go high, it's stable in the state, we actually have to change it by pressing this button there. And that sets the output high. Now, the output is high again. Or it's stable again, I mean. It's high, but it's stable. Before it was low, it was stable. And that's because I actually have to force it to go back low right there. So it's stable because it won't change. The button didn't make a good connection. It won't change until I press the button right there. So one thing to be aware with these buttons, they don't fit great into breadboards. In fact, when you first start inserting them, they'll pop out and stuff. You can file them down or whatever, so they'll work a little bit better. But usually it takes the board a little while to get used to them, and that's one reason why I stick them in the same spot right there, because it does modify the board a little bit. Higher quality boards take a little bit longer to get used to them because they maintain their shape. But in any case, we will look at the circuit with the schematic first. So first off, we have to disable pin 6 right there. If it gets a high input, 2/3 or more of the supply voltage, positive right there, then it will set the output high unless you're holding that button right there. But in any case, it'll set the output high, which we don't want it to ever do anything in this circuit, so we're not going to use it. We have to power the integrated circuit, pin 1 to negative supply, pin 5 to the positive. So let's assume that the output is low right now. We have 5 volts going to pin 2 through this 10K resistor right there because the switch is open. It's waiting for a low input. So we close the switch. It needs 1/3 or less of the supply voltage. 0 volts is as close to less as you can get. That's the most less you can get. So that's a direct connection. At that point, any current going through this resistor just goes right to ground. Pin 2 doesn't see that. It just sees 0 volts. So when it sees that, it sets the output high, as close to 3.5 volts, but as close to 5 volts as it can, probably about 3.5 volts in this circuit. And the red LED will light up. I got a lower value for the red LED because it doesn't get as bright as the blue LED at the same current, plus we're losing a little bit of voltage there. So a much lower value resistor there. Now, the output's going to stay high once we set it into place. And we have pin 4 here, the reset pin. That's what sets it low when pin 4 sees a low input right there. So to prevent it from accidentally seeing a low voltage due to stray signals in the area and everything, we have a 10K resistor connecting to 5 volts. And again, we press the switch. It's a direct connection to ground. It sees 0 volts. So that tells it set the output low right there. And that's when the blue LED lights up. So we got a 1000 ohm resistor again. Blue LED brighter than red at the same current, and also we have a better connection to ground. So 4 times, a little more than 4 times the resistance there for the blue LED. It ends up being about the same brightness. So that's really about all there is to it. Again, the reset sets it low, and the trigger pin number 2, sets it high. And I just kind of set the resistors out of the way. Also with these switches, another thing is that these 2 pins at the top there, they're always connected. Those 2 spots are always connected. So that's now one long row right there. Same with the bottom. That's all one long row. So I can put this on this side. When I press the button, it jumps across. All 4 of them. All 4 of the pins now are connected. So we can do that. I don't have to have everything on that side. That's not a separate switch. Sometimes there's relays and stuff where there's a switch on one side and a switch on the other. Even though they switch at the same time, they're completely independent. These switches are not like that. They're always connected across. So that's always something to pay attention to when you have multi-pin switches like this. And that's our disable, as I said before. And pin 4 is the reset, sets the output low. So when the output is low, again, that's a 1K resistor there, coming from positive. So now it's actually connected to ground right there. And you don't have to, have something low. Maybe you want it just to be off or high, But in any case, again, we don't need like a red LED, But the output's high whether we have the red LED there or not. Just something to be aware. So now it's connected. It's got to go through some transistors, so you lose some voltage. But there you can see positive making its way to negative through the 220 ohm resistor. So that's really about it for this. That's the bistable mode 555 timer. Bistable for 2 stable states unless we force it to change. So thanks for watching. Make sure you check out one of the other videos I'm posting on the screen and check out the links down below. They all help out a lot. I'll see you in the next video.